This is Calc BC, and it's Unit 6 Objective 3, and we're mostly dealing here with odd powers with trig functions. So they're kind of nice. Next lesson we get to deal with even powers of trig functions. Okay, now mostly I would say when we have odd powers of trig functions, you usually want to peel off whatever the trig function is, one of them, so that you have an even power left with whatever it is to the first power. So this sine to the fifth, we're going to peel off one of those sine x's. And so we have sine to the fourth times sine to the first. And then what we're going to do is we're going to get the one that's to an even power. We're going to get it to squared form. So sine squared. Of course, that means we'd have to raise it to the second power so that it's overall sine to the fourth times sine x dx. And then we want to keep in mind our Pythagorean identity substitution. So sine squared, we could trade that in for 1 minus cosine squared. Oops, I left off my sine x. It's very important, we want that. Okay, now, we don't have to do a U substitution, but perhaps it might be a little bit easier to think of in terms of a U substitution. You can do U equals the cosine x. And so du then is negative sine x dx, which we don't see the negative, but of course we can bring the negative over. And like I say, I mean, you don't have to actually do it. You could just multiply it out. But so anyway, what we have here is 1 minus u sorry, 1 minus u squared. Squared. Okay. And let's see, here's my negative and du, because my negative du replaces the sine x dx. Now, also, converting all the way to u-land, so cosine of 0 is 1, and cosine of pi over 2 is 0. Okay, and notice how it goes from 1 to 0 right now, and if we switch that, that would actually take care of the negative, so that's kind of a nice thing to do. And so I'm going to do that, so 0 to 1, and that takes care of the negative. And now we're also going to want to multiply out the 1 minus u squared squared, because we don't really have, you know, the derivative of the guts would be negative 2u, and I don't have the negative 2u there. So we want to go ahead and multiply this out, and so we get 1 minus 2u squared plus u to the fourth du. Okay, and integrate term by term now. So I have u minus 2/3 u cubed plus 1/5 u to the fifth, all evaluated from 0 to 1. Okay, so we have 1 minus 2/3 plus 1/5 minus a bunch of zeros okay, which is, let's see, we have 6/5 minus 2/3 And finishing that off, we would have, let's see, 18 minus 10/15, which is, and I don't want to go down to the next problem because I'm running out of space here, so I'm going to go up, and so that's 8/15. Okay, problem number 2 here. Problem number 2, integrating secant x dx. Now, perhaps maybe some of you might actually even remember that we did this problem in the last unit. It's just that they kind of helped set it up for us. I'm not sure, but probably most of you do not remember this. But anyway, we've carefully avoided this situation, and if you're just saying, well, I can just do 1 over cosine, and yes, that's a great idea, except for the fact that there's no, if we do the u as cosine x, there's no du. And so anyway, somebody somewhere along the line figured out that if we multiply the top and the bottom of secant x by tangent x plus secant x. Now, I have no idea who actually originally thought to do that. Now, we're multiplying by 1, so we're not changing the value of the original. And so what we have then is we have secant tangent plus secant squared up top, and on the bottom we have tangent x plus secant x. Okay, now if we do a u substitution, and generally if it's a fraction we look in the denominator, but it's not always the case. But if we look at the denominator, if u is tangent x plus secant x, then du would be the derivative of tangent is secant squared, and the derivative of secant is secant tangent. And of course, don't forget the dx. And at that point, you look and you go, oh my goodness, that is exactly what we have up top. Now, it's in reverse order, but because there's a plus there, remember, addition is commutative, so it really doesn't matter. And so, I mean, that's just a perfect substitution. And so, this becomes the integral of 1 over u du, which is, of course, natural log absolute value of u plus c. Don't forget the absolute value. Some of you forgot that in the last unit, and it's important to remember that absolute value. And now don't leave it in u land, so natural log absolute value of tangent x plus secant x plus a constant. Don't forget that constant. Now, that's what the integral of secant x is equal to. And so really, we've actually kind of come up with a formula here, and we can generalize it. Let's generalize it right now. Okay, so the integral of secant u du is equal to the natural log absolute value of, now I actually like doing a secant u plus tangent u because it makes me remember it a little bit easier. Secant u plus tangent u rolls off the tongue a little bit easier. I don't like that with u. Okay, and by the way, we could also come up with then the integral of cosecant u du, and we can do it in a very similar way. Now, what's nice about this, you know, it starts with a C, and so it's negative natural log absolute value cosecant u plus cotangent u plus a constant. Okay, so really you're almost getting two formulas for the price of one here. So if you remember the secant u, then the cosecant one is so similar that you basically have it. Okay, so one more problem coming up, and okay, it is the integral of secant cubed x dx. Okay, so what did I talk about if it's an odd power? Generally we peel off one of them. Okay, so that's what we're doing. So we have, and it doesn't really matter if you put it first or second. Okay, and now this one's an interesting one. So there's a little bit more to it than maybe we would originally think. You know, we can try some various things. I mean, you can try doing your trig substitution for the secant squared x, and you get tangent squared x plus 1, and you know, it's interesting, but you're kind of like a dog chasing its tail. It's, you know, it's just usually just doesn't work out well. And so what we can do is we can do this one by integration with parts. Okay, and so you know, it's like we got Liate, but they're both trig. And so anyway, what we can do though is we can say that the u, because the u is generally the one that we want to do easier derivatives of. So which one would be easier to do derivatives of, secant or secant squared? Well, secant is the easier one to do derivatives with. So u du then would be secant x tangent x dx. Okay, and then the dv is whatever left. So secant squared x dx. And so the reason why it was nice to choose this one over here is the u equals secant x. So secant squared, that one's easy to do integration with, because secant squared is the derivative of tangent. Okay, and so we get the fact that this is equal to, okay, uv, so secant x tangent x minus integral v du. Okay, so v du, so if we multiply those we get secant x tan squared x dx. Okay, so now moving along here, and I'm kind of running out of space here, so I'm going to move it down here. Now I got to bring along the secant x tangent x minus, okay, now at this point I am going to substitute for tangent squared. So I have secant x times secant, tangent squared would be secant squared x minus 1. Okay, and now if I distribute the secant x, we get secant x tangent x minus, and I've got secant cubed x minus secant x dx. And I know you guys are thinking, it seems like we're not making very good progress here. But let me rewrite what we started with here. We had secant cubed x dx equals, okay, so I have secant x tan x. Okay, I'm going to distribute the negative here, and I'm going to break it up so I'm integrating term by term. So I have minus secant cubed x dx, and then if I distribute the negative, I get plus integral of secant x dx. Okay, now the secant x dx, we just learned how to do that. Okay, we just learned how to do that, so we can deal with that part of it right now. So we have secant cubed x dx equals secant x tan x minus secant cubed x dx plus natural log absolute value secant x plus tan x. And I'm going to go ahead and do the plus c right now. Now, what's left to do? How in the world do I deal with this negative secant cubed x dx? But hopefully you're looking and you're going, wait, that's the same thing as we have over here on the left-hand side. That's correct. So if I move this one to get it to the other side, they're like terms, and so I have one of those plus another one of those, and so now I have two of those things, and I'm left with secant x tan x plus natural log absolute value secant x plus tan x plus c. So how do I finish solving? Well, all I got to do is multiply the whole thing by 1/2 or divide by 2. So if I multiply by 1/2, we get the integral of secant cubed x dx is equal to 1/2 secant x tan x plus 1/2 natural log absolute value secant x plus tan x plus what's 1/2 times a constant? It's a constant. Okay, and so there it is. That's pretty kind of fun and amazing.